bottom as our 0 point. B, calculate the change in the gravitational potential energy by setting top as our 0 point. Okay. So you have something like this. Okay, this is so a block sliding from the top to the bottom, and the height here is 15 meters. The length of the incline is 25 meters. We want to calculate the potential energy change. So if we call the initial point A, the final point B, so we want to calculate the potential energy change from A to B. By definition, it's delta U equals to the change in the potential energy equals to the final potential energy, UB, subtract the initial potential energy, UA, right? Okay. So we need first calculate UA and UB. First, we want to choose our 0 reference point, and here. Okay, and the bottom is ground. Now let's try to calculate UA and UB. So UA, by definition, okay, remember how to calculate the potential energy, gravitational potential energy. It's mg YA, right? So here mass equals to 10, and we can also use 10 for gravitational constants. So this will be 10 multiplied by 10 multiplied by what? What is YA? 15 meters, okay, the height of point A. So it will give you 1500 joules. Now, if we calculate UB, what am I going to get? 0, right? Because it adds up, we choose the bottom as our 0 reference. So the height of the bottom is 0, and it will give you 0 potential energy. Gravitational potential energy. And then of course UA minus delta U equals to UB minus UA. So 0 minus this equals negative 1500 joules. Okay. So the potential energy change is negative 15 joule. Okay, from here to here. That's something you can see from if some object from higher position to a lower position, the potential energy will decrease. So that's why you get a negative sign. Now, this is part A. For part B, we are going to choose the top point here as our 0. Okay? Now let's look at UA, UB, and delta U. So in this case, UA, what's UA? If we choose part B, if we choose top as our 0 reference. So UA equals to 0, right? And UB will be mg YB equals to 10 times 10. What is YB here? Negative 15, right? This height is 15, but it's below our 0 point. So it's negative 15. And you will get negative 1500. And then delta U will be UB minus UA. So negative 1500 minus 0, still negative 1500. Okay. So if you compare the answers for part A and part B, you can see delta U calculated here the same as delta U calculated here. Okay, question? But UA is different with this UA. UB is different with this UB. Delta U is the same. Okay. So, question?
I don't understand why UA and UB are 0. Can you explain to me?
Okay. So, if this is your 0 point, B is here, what is the height of point B?
0.
0.
Right.
And then 10 multiplied by 10 multiplied by 0, what's that?
0.
0, right? Okay.
So the endpoint at the bottom is 0.
Hmm?
Never mind. I got it.
Okay, in this graph, so UB goes to 0. But here we choose top as 0. So UA is 0. Okay, so again, it's trying to illustrate the fact that the potential energy you calculated there at any point, you may have different value, but change in potential energy is always the same. Okay. But one comment here I would like to make is that previous slides we talked about the potential energy at any point has to have the same value. And here we talk about the potential energy and one point has different value. Do I contradict myself with these two things? Okay, we're talking about different things. From the previous slide says that even at, okay, so here we can have different value for the same point because we make different choice of the 0 point. Okay. But after we make the choice of the 0 point, then the value becomes unique in this calculation, right? So when you do the calculation, you have to make some choice. But once you say, here is our 0 height, so this point is 0, it wouldn't change, right? But here we're talking about, in this kind of non-conservative force, even you already choose the 0 point, you cannot make unified the unique value. Okay, so then in that case you cannot have potential energy. Okay, any question here? Now, part C, we're going to calculate the work. Okay, so here, again, I will emphasize your purpose is this is ridiculous. But we always give you all kinds of these things. Say, okay, you don't have unique value. You have to choose it. You have to think about that. What you are going to choose. What's the value? Why we just give you say, okay, we make some convention. Everything has fixed value. But in fact, you cannot do that. Otherwise, most of the problem would be very hard to solve it. Okay, we have to allow the freedom so we can be more powerful, right? Without freedom, we don't have power. So let's look at part C. We want to calculate the work done by the gravitational force. In fact, here, if you record this, U equals to negative WC. Okay. You can probably quickly tell me the answer in part C. What will be the work done by the gravitational force? 1500, right? The change in the gravitational potential energy equals to the negative value of the work done by the gravitational force. So here is negative 1500. So the work must be 1500. And here we can, what I'm going to do, I will directly calculate the work done by the gravitational force from the definition and to check if we got 1500 here. So if we use the work, the definition of the work, W equals to force multiplied by distance multiplied by cosine theta, right? So if we want to calculate the work done by the gravitational force, it should be the gravitational force multiplied by the distance multiplied by cosine theta g. of course, here you get 10 multiplied by 10. What is the distance d? 25 or 15? 25. To calculate the work, you have to use the actual distance, okay, the traveling distance, initial point to the final point. And then you need to put the angle here, theta g, okay? So the angle should be this angle. You have the gravitational force, mg, is along this direction, right? And the motion is along this direction. So it should be the angle between the two directions. So this will be our angle theta g. So you have to find out this angle. And is it possible to find this angle from the geometry? Yes, because we have some triangle here. We know that the hypotenuse is 25, the adjacent side is 15. So if you're looking at the cosine function of this angle, you get this theta g. So cosine theta g equals to 15 over 25, right? So that indicates theta g has to be inverse cosine of 15 over 25. Okay. In fact, you can see that it has to be 53.1. You can calculate that. Then you put this angle here. You are going to get this is 2500 multiplied by cosine 53.1 is 0.6. We get 1500.